Yo, what's up? Spring break came early, or COVID-19 did. So if you're watching this, you're definitely sitting at the house, and this will be your 6.4 Trapezoidal Rule notes. I hope they help, and I hope you like it. Let's get started. So with the Trapezoidal Rule, alright, this is the most accurate and less wasteful compared to the rectangular rule. Alright, the trapezoidal rule is because the rectangular rule, when you make those rectangles, you're leaving off some of the area. Alright, so this is a little bit more accurate. Okay. Couple things here. Alright, if it is continuous on A and B, then here's the rule right here. Alright, the main thing I want you to take note of is this right here, b minus a over 2n. Alright, when we write this thing out, and even this pattern, let me talk about this pattern too. The biggest thing to remember is the coefficients of the trapezoidal rule have a 1, 2, 2, 2, etc. 2, 2 pattern, or 1 pattern. Alright, I'm going to show what all this means here on your first example. Alright, but make sure you are familiar with this. Alright, also make sure you know how to find delta x again. Alright, remember delta x is how wide each trapezoid is. So that's going to be b minus a over n. Alright, don't forget that, b minus a over n. Which essentially, this is the same thing, b minus a over n, just times 1/2. If you multiply by 1/2, that's what this is, okay? Alright, let's jump right into the first example right here. Let me make this bigger so I have plenty of space to write. Excuse me. Alright, use the trapezoidal rule with n equals 4 to approximate from 0 to 1 of each of the 2x dx. So first off, what I want to do is go ahead and find my delta x, because delta x tells me how wide each trapezoid is going to be. Alright, so, or how I'm going to number my number line. Alright, so I have 1 minus 0, b minus a over n, and n is said to be 4, which is right here. I know you can't see it, but n is 4. Alright, so that gives me 1/4. So if I drew this graph, right, hypothetically, and I'm going to just do it with a simple number line. Alright, well, I would start with 0. I would end with 1. Alright, and then everything in between is 1/4 apart. So this is 1/4, this is 2/4, this is 3/4, and then 1. So I could actually make this a little more equal distance, but 2/4. Alright, 2/4 or 1/2. You also say 1/2, right? Doesn't matter. And then 4/4 is 1, right? So everything is a 1/4 wide. Alright, now unlike left Riemann sum, we would only use these 4, or right Riemann sum, we would only use from here over to this one. And even the middle Riemann sum, we would use this one, the midpoint, so the eighths, right? Well, we're not going to do that here. We're going to use each one. But here's how you write it out. It's a little different. So when you graph this and evaluate it, you're going to evaluate it. Remember that equation I told you got to remember, which is right here, b minus a over 2n. All right. So here you're going to go b minus a over 2n. All right. So when we actually solve this, or the approximation, I'm going to write this off to the side, b minus a over 2n. Again, that's delta x over 2n. So, or b minus a over 2n. So that gives us basically 1/4 times 1/2, which is 1/8. But I'm just going to show you 1 minus 0 over 2 times 4 is 1/8. All right. That's 1/8. So now when I find this approximation, what I'm going to do is I'm going to evaluate this whole thing for 1/8 times, and look, remember that pattern where it was 1, 2, 2, 2, 2, 2. So the first value we're going to multiply or we're going to evaluate for is f of 0. All right, f of 0. All right, and this 1 times f of 0. So I normally don't write the 1, but for the sake of instructional purposes, I'm going to show you. All right, and then you're going to do 2 times f of 1/4, because it's 1, 2, 2, 2, 2. All right, and then 2 times f of 2/4. And then you have 2 times f of 3/4. All right. And finally, you have f of 4/4 or f of 1. Now notice this one, I didn't multiply this first one or this last one by 2. All right, all the middle terms, all right, will be multiplied by 2 when you evaluate f, okay? But the first term and the last term, all right, they're essentially y values, so you don't have to multiply those by 2. All right, so do not just multiply the first term and the last term. Everything in the middle gets multiplied by 2. The first term and the last term, you just write it f of 0, f of 1, or evaluate it 1 times f of 0 or 1 times f of 1. So now we're going to let our calculator do some work for us. So let's go ahead and plug this function into our calculator. So there's our function right there. All right, e to the 2x. Now, before I graph it, what I want to do is I want to go over here to window. I want to change, second window. All right, because I want table set. I want to change this from auto to ask because I'm looking for specific values. All right, so I go to the independent variable. It's normally set on auto. We want to slide over to ask. All right, because I want to ask. I want to put specific values in there. Now I'm going to hit graph, and your graph should look like this. All right, and now we're going to press second and graph again because I want the table. Man, what, bro? Oh, I'm not pressing second. I'm tripping. There we go. So when you go to the table, now I want to put my x values in. Okay, so I start with 0, and then I want 1/4, and then I want 2/4 or 1/2. And then I want 3/4 and 4/4, which is 1, right? So it's already that 1 is there. I don't need this one, that's 2. We leave that one out. All right. So those are our values right there. So these are the answers we need, okay? So write those down because you're gonna need them. You need these values right here because this is the evaluation. This is the evaluation of e to the 2x. So e to the 2 times 0 is 1. E to the 1/4, 2 times 1/4 is this. E to the 2 times 1/2 is this, right? So this is the function being evaluated in terms of those x values. So write those down because you need them. And now I'm going to go back over here so we can actually evaluate this whole thing. So we have 1/8 times, remember this is 1 times f of 0, and we said f of 0 was 1. So 1 times 1 is 1. Now for this one I have 2 times f of 1/4. Well, f of 1/4 was 1.6487. All right, now I'm using 4 decimal places because that's what it gave me, but also I want to be as accurate as possible. All right, and then 2 times f of 2/4 or 1/2 was going to be 2.7183. And then we have 2 times f of 3/4, which was 4.487. No, 2 times 4.4817. And then we have 1 times f of 1, or just f of 1, which is 7.3891. All right. Now, this whole thing, all right, now again, please pay attention, only these middle values were multiplied by 2. The first one and the last one was not, okay? Now, you could punch this in your calculator, right? Put that whole thing in your calculator. When you do that for our approximation, we're going to get 3.26 as our approximation. Okay, so our approximation is 3.26. Now, what we're going to do is find the exact real quick. All right, so you can see how that's done. And remember, that's using the math 9 function, math 9. All right, so I'm going to go back to the calculator real quick. And I'm going to press math. Oops. And so let's see, quit this. All right, I'm going to press math and then 9. And now I can put it in. So from 0 to 1 of E, look, E is right here second, and ln. All right, E to the 2x. And then in terms of dx. All right, and we, I didn't mean to press graph. Quit that. Hit enter. There we go. 3.19. All right, 3.19. Force of 3.19. So the exact area right here is 3.19. All right, so that's the approximation. It's a little over, but 3.26, 3.19. All right. Now I got one more example for you. All right, this one says use the trapezoidal rule. With n equal to 5 to approximate this value. So again, because you gotta sketch it. All right, I'm sure you're gonna have to sketch it. Let's first find delta x. So delta x is going to be b minus a, so 0 and 1. So 1 minus 0 over 5 equals 1/5. So when I do my number line here, I start at 0. All right, I'm going to count about fifths. So 1/5, 2/5, 3/5, 4/5, and 1. All right. And then of course you graph it and sketch it. Okay. So now just for solving it real quick, I first need to write this out. I need to find the first part is going to be 1 minus 0 over 2 times 5. All right, and that's 1/10. 1/10, man. So that gives me 1/10 times f of 1/5. I mean f of 0. Sorry, f of 0 plus 2 times f of 1/5. All right, etc. So I'm gonna write it out. All right, plus 2 times f of 3/5 plus 2 times f of 3/5 times 2 times f of 4/5 plus f of 5/5 or 1. All right. Again, the last two terms will not be getting multiplied by 2. All right. I just want to harp on that so you don't make that mistake. Now, real quick, we need to put our equation. All right. 1 plus x squared into the calculator, square root of 1 plus x squared in the calculator, like so. All right, so we hit graph. All right, so there's our graph. By the way, guys, if you want that perfect picture, press zoom and then option 0. All right, option 0 is zoom fit. All right, and then it'll give you a better picture of your graph. All right. Now, anyway, second table, because I want to input my values, so I start with 0. And then I want 1/5, and then 2/5, and then 3/5. Yeah, that's right. 3/5, 4/5, and then 5/5 or 1. All right, so go ahead and write those down. All right, so you have a reference. And let's use those to actually solve this thing. So hopefully you wrote those down now. So now I have for the approximation. We have 1/10 we have have 1/10 times f of 0, which is 1. Alright, plus 2 times f of 1/5 is 1.0198. Alright, plus 2 times f of 2, which is 1.077. Plus 2 times 1.1662. Plus 2 times 1.806. Plus 1.4142. And again, notice I did not multiply this last one or this first one by 2. Only everything in between those two. Alright. So you can punch that in your calculator, and when you do so, you get an approximation of 1.15. Alright. Now, real quick, I'm going to do the exact one. Alright. So with the exact, we're going to integrate from 0 to 1 of the square root of 1 plus x squared. And when we do that using our calculator, remember math 9. Alright, we can integrate. So math 9. Oh man, didn't mean to put it here. There we go. Math 9 we have from 0 to 1. Whoa, I'm having technical issues right here. Alright, math 9. 0 to 1 of second. Hit the x squared button. That's your square root of 1 plus s squared. In terms of x, or with respect to x, dx. And enter. 1.14, 1.15. You see it? So just if I kept doing 2 decimal places, 1.14, or we can even say 1.15. All right, you saw it's really close, right? All right. Before I conclude this, I just want to show you a couple tips. All right, because this concludes the lesson. I just want to show you a couple steps. If you follow, you'd always be pretty spot on. So and these rules right here, man, one, remember graph it and use zoom fit, which you just press zoom and then option 0, and that'll give you a nice picture. All right. And then 2, create your delta x by doing b minus a over n to create the intervals. All right. And use the intervals on your number line. All right. That's how you break it apart. Right here, then you want to create your formula, your approximation formula. All right. Doing b minus a over 2n, and when you evaluate it, f of the first term, all right, plus 2 times f of the second term plus, or the second interval, plus 2 times f of the third interval, all right, and etc. until you get to the last interval. All right, do not multiply that by 2. All right, the first and the last interval, don't multiply those by 2. Now, doing this will give you your approximation area. All right, and after you find your approximation, find your exact area. Well, hey, that concludes your videos. Make sure if you got any questions, man, send an email or refer back to the video. And also, wash your hands. Stay COVID free. Catch you later.